Hello there, this is a video for Geometry Chapter 3, Section 4, Equations of Lines. And it should be quite the review because you learned all of this in Algebra 1. And if you didn't, well, you're going to have a sad time today. Alright, so, want to remind you of two different forms of equations of lines. We have our, first up, our slope-intercept form, our one and only y equals mx plus b. Whenever I ask someone for slope, they always give me that equation. And it's not the slope equation, it's slope-intercept form of a line. And then we have point slope. So the slope-intercept form, then each name of each equation actually has in its name why it's called that. In other words, like slope-intercept is called slope-intercept because it requires two things. One, the slope, duh, okay. And two, it requires the y-intercept, which of course we have the 0b. Point slope form requires also two things. It requires a slope, but it requires any point. So the difference between the two is that in the case of slope-intercept, you have to have the y-intercept. And you know you have the y-intercept because the x-coordinate is 0. In the case of point slope, however, you can pick any point. It doesn't have to be the y-intercept. It can be any point you want. And so this is the equation for point slope. And of course we have our x1, y1, our slope, and there's your equation. But again, this is all from Algebra 1, so it should be really straightforward. So I'm going to show you some examples just to kind of refresh your memory on how all this stuff works. So here's example 1. It says write an equation in slope-intercept form, and again that's y equals mx plus b, of the line with slope 3. So we are told that the slope is 3, and that the y-intercept, why did that not change to black? Okay, there we go. And the y-intercept is -2. So there we have our slope and our y-intercept. And to write the equation, it's very simple. We go y equals m, and since m is 3, so we get y equals 3x. And then since our y-intercept is -2, there's our line. Y equals 3x minus 2. So, to graph it, we're going to plot -2. So here's -2. We're going to put a point right there. And then we're going to use our slope to get a second point. And if you remember the slope from the previous lesson, our slope is rise over run. So from this point, I want to go up 3 units. So 1, 2, 3, and to the right 1 unit. Do that again, 1, 2, 3, and to the right 1. You can even go backwards and go down 3 and left 1, and we're still going to have the same line. So here we go. I'm not sure people are laughing at me, but it's okay. So there you go. That is how you write an equation in slope-intercept form and how you graph the line. Sounds pretty cool, huh? So now you're going to get a chance to do it on your own. And then we're going to move on to another example. Example dos. And this time we're going to be writing an equation in point slope form. That's a different equation, a different formula. So in this case, they're telling us again that slope is -3/4. And they're telling us that our point, our line here is -2,5. So the point is -2,5. Now obviously, we can tell from this that this is not the y-intercept because the x-coordinate is not 0. So we're going to plug it into our formula, which says y minus y1. And it is important that you label your point. We're going to call this x1, y1. So my y1 right now is 5. Then we're going to have equals m, and m is -3/4. X minus, and x1 happens to be -2. And then we can go ahead and simplify our answer here. This is going to be y minus 5 equals -3/4 x, and a negative instead of +2. So this is actually the equation of the line in point slope form, but they also want us to graph the line. So in this case, we don't have the y-intercept, so we can't graph that. But we do have this point right here, which is -2,5. So we're going to go ahead and start with that guy. So x is -1, -2, and y is +5. So 1, 2, 3, 4, 5, right about here. There's my point. And then my slope is negative 3/4. So that means that starting from this point here, I'm going to go down 3. So 1, 2, 3, and to the right 4. 1, 2, 3, 4. Put my second point there. Connect the two. And there's my line. Easy peasy Japanesey, just like that. So now you're going to get a chance to do one of your own right there. And then we will move on to our next big and wonderful thing. So in this case, it says write an equation of the line through each pair of points, and they want it in slope-intercept form. So the difference between these two examples is that in this case, we are given the y-intercept because we know that the x-coordinate is 0. So in part A, we're going to have an easier time. In part B, we are not given the y-intercept, so we're going to have to use a different equation for that one. So let's start with part A. The first thing we need is a slope. We do not know the slope right now. They did not give it to us. But lucky us, we know how to calculate slope, so we're going to go ahead and label our points x1, y1, x2, y2. And our slope is going to be y1, sorry, not y1, y2, negative 1, minus y1, which is 3, all divided by x2, which is 2, minus x1, which is 0. Negative 1 minus 3 is negative 4. Last I checked. 2 minus 0 is 2. And negative 4 divided by 2 is negative 2. So our slope is negative 2. And that's all we need. Our equation will be y equals m, which is negative 2, x plus b. And since we have the y-intercept, b is 3. So there we go, negative 2x plus 3. And you're done with part A. Part B is going to be a little trickier. We are going to have to find the slope nonetheless. x1, y1, x2, y2, just going to label my points here. And to find the slope this time, we're going to go negative 4 minus 4 over 9 minus negative 7. So y2 minus y1 and 9 minus negative 7. Be careful with those minus negatives. Negative 4 minus 4 is negative 8. And then 9 plus 7 is going to be 16. And luckily, 8 goes into 8 una vez. And 8 goes into 16 2 times. So your slope is negative 1/2. So now we're going to go to our point slope form, which is y minus y1. And y1 is 4. And then m was negative 1/2. And then x minus and x1 is negative 7. So now I'm using point slope formula because I don't have the y-intercept. So I'm going to go ahead and put it onto my formula, and then I'm going to simplify because in this example, they don't want me to leave it in point slope form. They want me to put it in slope-intercept form. So I have to keep going and keep simplifying this. So I'm going to get y minus 4 equals negative 1/2 times x. With a negative, negative is going to be a plus. And then we have to distribute that negative 1/2. So we're going to get negative 1/2 x minus 7/2. Then we're going to add 4 to both sides. And eventually we'll get y equals negative 1/2 x. And 4 is the same thing as 8 over 2. 8 divided by 2 is 4. So 8/2 minus 7/2 is going to be 1/2. And so at the end of the day, this is our slope-intercept form. But we have to start with point slope and then simplify it to slope-intercept. So that's how you do that. And you will now try this example on your own. And then we will carry on to this wonderfulness. Want to give you a little summary of horizontal and vertical line equations. So over here on the left we have horizontal, kind of looks like the horizon. Ta-da, horizon. Vertical, like vertical lines up and down. But more importantly is this information down here. The equation of a horizontal line is always y equals b, and b could be any number, and b is the y-intercept. It's where the line crosses the y-axis. The slope of the horizontal line is always 0 because there is no change in y, so you get a slope of 0. In the case of the vertical, you have x equals a, and a ends up being the x-intercept, the place where the line crosses on the x-axis. And the slope of a vertical line is always undefined. That's because there's no change in x, and the change in x is on the bottom. So division by 0 is undefined. So that's kind of your summary on horizontal and vertical line equations. And so I want you to do this example here. So it says write an equation of the line through -2, 6, and 5, 6 in slope-intercept form. You might notice by looking at the two points that they have the same y-coordinate. So when I calculate the slope, I'm going to get 0 because there's no change in y. And we just said earlier that when there's no change in y, your slope is 0. But even if you don't notice that right away, you can still figure it out by doing the slope formula. So I'm going to go ahead and do that now so you can see how it works. So here's x1, y1, label, label, label. And my slope is going to equal y2 minus y1 over x2 minus x1. So you can see how on the top I get 6 minus 6 is 0. On the bottom I get 5 plus 2 is 7. But 0 divided by anything is 0. So you can see how I said earlier, you're going to get a 0 slope. So the equation of the line is going to be the equation of a horizontal line. And so my answer for this question will simply be y equals 6. Okay? Because the y coordinates here are 6. So y equals 6. Technically it's y equals 0x plus 6, but since 0x is 0, then we just get y equals 6. So in do it yourself number 4 is right here below. You don't have to switch screens. It's right there, right below this example. And then I believe we have one more example for you, and then we will call it a day. So our last example says, write an equation in slope-intercept form. Again, that's y equals mx plus b for a line perpendicular to y equals -3x plus 2 containing 4, 0. Now, you don't have to draw this graph on your notes if you don't want to. I just wanted you to kind of understand what the question was asking in case you didn't. So what I've done is I've actually drawn out the line y equals -3x plus 2. I have a y-intercept of 2 and down 3 over 1. So I drew the line, and then I have the point 4, 0 over here. 1, 2, 3, 4, x is 4, y is 0. So here's my point. So what this question is asking us to do is to find the equation of a line that is perpendicular to this one. So if I were to draw this line like this right now, that is not perpendicular. We want the line to actually be perpendicular, make a 90-degree angle with the pink line. And furthermore, we can do that all along. We can have a line here, a line here, a line here, a line here. All of these lines will be perpendicular. But not only do we want it to be perpendicular, we want it to go through the point 4, 0. So it has to cross through this point and be perpendicular to this line. So basically, we're looking for a line that is right about there. That's what we're looking for. So again, you don't have to draw the graph. I just wanted to explain to you what we're doing. So the first thing we have to do is find a slope. And since the slope of this line is -3, we need a perpendicular slope. And we learned that in the previous lesson. A perpendicular slope would be negative reciprocal. So if this one's negative, then we need positive. If this is 3 over 1, then we need 1 over 3. So for our line, we need a slope of 1/3, and we already have a point x1, y1. So we can use our point slope formula, which says y minus y1, which is 0, is equal to our slope, which we know is 1/3, x minus, and x1 is 4. So this is basically what we're going to do. We're just going to simplify this equation and we'll be done. So we're going to go y minus 0 is just y. 1/3 times x is 1/3 x, and then minus 4/3. So this is the equation of a line that is perpendicular to -3x plus 2, and at the same time crosses through 4, 0. So we can even graph it. -4/3 is basically -1 and 1/3. So here's -1 and here's -2, so -1/3 is right about there. And then we know it has to go to that point, so we're going to just do this little guy. And what we are saying is that we're not perfect, but this should be perpendicular right there. So again, you don't have to draw that graph. I just wanted to show you what you are doing. So in this case, we're going to have you do one for yourself. Just keep in mind that this is not the same thing. This is asking for parallel. In the case of parallel, you want the slopes to be the same, not negative reciprocals. But the idea is very similar. So once you do this example, you will have completed your notes for this lesson. I will see you in class, and thank you for watching.